so what we're going to be doing this year is we're going to be learning a programming language that is very, very similar to the language that you guys learned in grade 10, but the language is Java, okay? And what I want you guys to remember is one word this year that's going to be crucially important to learning Java. One word. And that word is class, okay? Now, I know you've heard that word before. You're in a class right now. Class has words that derive from it, like classification. To classify something or to put something into a classification means it fits into a category, right? Like, I could classify this as a cup, right? I could classify this as a remote. Or I could classify this as electronics. Or I could classify this as a projector remote. Each time it got either a little bit more specific or less specific. Okay. Two things that I want to branch off of what a class is are, again, going to be crucial to this course, and actually a little bit later in the course. A class consists of properties, okay? And what properties are let me just shorten that, are things about it, okay? So if I said, what are things about this cup? Well, you could say, well, it has a size, it has a shape, it has a color, it has a weight. Those are things about it. But the other thing that's important with class is what are called methods. And what methods are not things about it, but they're things you can do with it. Okay? So in the case of this cup, I can drink from it. I can fill it. I can use it as a projectile to throw at somebody. I could use it as a club to club one of you. This is getting me excited, but those are things I can do with it. Okay? So properties are things about it. Methods are things you can do with it. And we can classify all kinds of things that way, right? Like this toy here. I can classify things about it, like color, shape, the density, the materials it's made of, and things you can do with it. If I open this door right now and some student walked by, you could classify that student. You could, things about it, things you could do with it. Be careful. I'm not getting into the dating world with you kids, but these are some of the things that we do. And this will relate to programming. Because spinning off of this, spinning off of a class, is an object. Okay, so object and class are related. And we'll get into that when we do the unit on this. But then object is the basis of object-oriented programming, or OOP, which is really the revolution in programming that's kind of taken us to where we are now. Object-oriented programming has made things like graphic programming and advanced games and stuff like that. All of that's been possible because of some of the revolutions done in object-oriented programming. So I'm going to build a foundation that leads towards that. And believe it or not, I have talked about this with you before. We did kind of cover some of this stuff in grade 10. You may have recalled back in grade 10, I think I used this stool as the example. When we first started programming, I believe I put it up here and I said, things about it, things you can do with it. But at the time in grade 10, it was just sort of conceptual. This year, we're going to make much more detail on how that works. But let's start with Java. What is this Java, and why am I going to teach it to you guys this semester? Well, Java is an object-oriented programming language. It was designed to be that. That's what it was designed to be, is this object-oriented programming language. So, come on, there we go. A little cartoon for you. Okay, I'm going to skip through that. So let me just start with a little bit of history lesson, just for interest's sake. So Java evolved from other languages. Okay? Believe it or not, we can actually trace its origins all the way back to 1967, and there was originally a language called B. It was a programming language. Okay? And B was actually one of the languages used to develop the first Unix operating system. Unix you may not have heard of, but you may have heard of its predecessor Linux. Similar idea. And what you're going to learn through this history lesson is that computer scientists are terrible at naming things. Terrible at it. Okay? B would evolve in 1972 into the language C. Here's an example. Oh, we have to come up with a new language. Why not? Well, we called it B. How about C? Right? And in the late 1970s, C was being widely used, and believe it or not, is actually still used quite a bit today, to write programs. And what was nice about C is they had what's called a portability to them, which means the software you write could be used on multiple pieces of hardware. So you could write software that would work on different pieces of hardware. That was the idea of portability. And we're going to expand on that as we continue the history here. So C would evolve into C++, which, believe it or not, that name is supposed to be a joke, which you may recall from, say, the grade 10 content, really just means C plus 1. That's what it means. And it was developed in the 80s by Bjorn Strostrup to take the C language and extend it into using this new kind of concept called objects. So to take C and make it into an object-oriented programming language is what C++ was. Okay? The other name for C was just C. C++ was C with classes. So here's that word coming into play. The idea of C++ was to take C and extend it into this new idea of making classes. So a class, in terms of the technical details, is a piece of code separate from your main piece of code. So it's a whole other piece of code that is separate but connected to your code. Okay, and we're going to get into the concept of it, which we already did a minute ago. So what programmers found is this idea of object-oriented programming, and using C++, for example, made graphics programming a lot better. Okay? This is where revolutions in companies like Macintosh and Microsoft Windows would use this type of programming to build operating systems that people liked because they were graphical in nature. Okay? C++ is what's called a compiled language versus other languages like, for example, Visual Basic, an older language, which is an interpreted language. The difference is, and you had this in C# last year, is that compiled languages versus interpreted is whether it runs your code one line at a time or runs all of it at once. In a interpreted language, it'll run one line at a time and look for errors as it's running it. Okay? And if it encounters an error, it'll stop on the line that caused the error. But with compiled languages, it goes through all the code first before it runs it. Okay? So this is an example of some C++ code. It would go through all this code, see if there's any errors. If there isn't, then it runs it. Okay? Now, there might be errors in your logic, but there's certainly no errors in the way the code is written. Okay. Now, the difference is, though, when it is an interpreted language versus a compiled, is it's going to perform better. If it's compiled, it will run better on the operating system that it's compiled for. Okay? As well, you can compile it for different operating systems. And what you're going to see this year with Java, which you couldn't do in C#, is you can write code and then run it on a Mac or run it on Linux. And it can run on different pieces of hardware. It can run on a PC, or it can run on a tablet, or it could maybe run on a smartphone. So the software itself doesn't change, like the code doesn't change, just the way it's compiled changes, which is not something you have to worry about, okay? Which is this idea of portability, okay? So compiled programs can run on whatever system they're compiled for. Okay. For many years, intro programming courses were taught in Pascal, or I used to teach it in Visual Basic. I taught it to you guys in C#, but a lot of the intro programming languages follow what's called a structured programming paradigm. They work sort of line to line, and you work through a structure that way, which is good programming. But I want to expand that in grade 11 to introduce object-oriented programming, which is a higher level type of programming to work on. Okay? We're going to get there. That's a later unit we're going to get to. Okay, and this is actually some notes from slides I gave you in grade 10. So I'm going to go through it quickly, and I just did the same thing with you guys. If you look around the world and you see objects, we can classify them according to properties and methods or functions. Okay? In programming, objects will make out different parts of your program. Okay? And there's a relationship to those objects as well, which we'll get into when we get a little more advanced. So for example, if you think of a person as an object, that person can be made up of sub-objects. So person can have a head, a person can have a body. The head can have sub-objects, right? Like a nose and a mouth. And the body can have arm, and arm can have hand. So all these objects are all interrelated to one another. Now, some terminology we'll get into later in the year. Objects that are below other objects or connected through it in that relationship are called sub-objects or subclasses. And here's a fancier word. Objects that are above are called superclasses. So for example, person is the superclass of body. Body is a subclass of person. Don't worry about this stuff in terms of terminology. I'm just introducing it to you now. I'm dropping this down. See if it sticks a little bit later in the course. Okay? You can travel through these objects using what's called dot notation. And you saw this last year. That's what you'd use. You use a dot to travel through the objects, right? So for example, I could go person.body.arm.hand to access the specific object. Okay? And then they have properties. And you saw this last year. Head can have a size, a color, and a shape. And you can sometimes change those properties. Head.size equals large. Head.color equals green. Head.shape equals square. The property change should affect the object that we're talking about in our code. I did this with you guys last year, and it was to introduce basic programming. So why am I doing it again? Because we're going to go deeper this year into more content on that as we go a little bit further along. Okay. And then objects can also have methods. Now, this was not something I totally introduced in grade 10, and you'll notice methods is the very first unit we're going to do after the intro. So methods will be a unit into itself. A method can perform a task and return a result. Another name for a method is a function, which is what I talked about yesterday. If you are, for example, doing pre-cal math and you've done a unit in functions, or you did one last year, then this is going to look familiar to you because this is the same kind of concept as you'd find in a function in math. Okay? Different structure to it because it's computer science, but same concepts. Okay? Okay. So the benefit of writing code into this idea of objects is it will eventually result in faster development times or rapid application development, right? To make apps faster. Because these objects that we can use will be ones that you can write.
Sweetie.
Hi.
Hi, there's Christian Henry in class.
Yep.
If you could please come to the office.
Okay.
Thank you.
The other thing about objects is they can be made by other people. So you can use objects that are made by other people as well. Okay. So we get shorter development cycles, easier to maintain code, reusable objects, and programmers can develop objects for other programmers. This is what made programming become more robust. Obviously, in this type of teaching environment, I'm just introducing this to you guys, but these are some of the reasons why object-oriented programming is the stuff of the programmers in the modern eras. Okay. So computer scientists have discovered that using this idea of creating code that kind of takes care of itself or is classified or is in this idea of objects makes for better, more stronger, and more robust programming. Okay, back to the history lesson. So microprocessors, the hardware, started developing through the 1980s and the early 1990s. And what they believed was that in the early 90s, that this development in hardware would result in a lot of computer electronic devices for consumers that were really, really revolutionary. They had, in the early 90s, had this thought that they could build computer technology into almost anything. Now remember, I'm saying in the early 90s. It was a little sluggish. We now are seeing this happen, and have seen it happen, where we have tablets and we have smart TVs. We even have internet-based refrigerators. But in the early 90s, they kind of foresaw that this was going to happen, but the actual hardware wasn't quite there yet. So in recognition of this, in 1991, a company called Sun Microsystems started working on a project called Project Green. And they were a software company. They weren't a hardware company. But they said, you know what? Let's take C++ and let's make a programming language that can work on all this really cool hardware that's coming down the pipe. So that was their project, is let's going to make a programming language that can work across multiple pieces of hardware. And the creator and the guy who ran this project looked out his window of his office, of which there was a large oak tree, and said, you know what, let's call our project Project Oak. Like I said, they have terrible naming. So he named it after a tree outside his window. So like all companies, he goes to put a patent on this name Oak for his new software. Unfortunately, there already was a software development program called Oak. So he's like, oh, what am I going to do? So him and his partners went across the street to the coffee shop to come up with a new name for their software, and they came up with Java. Yes, that's how it came. That's the story as to how it came up. This is, again, where programmers have terrible abilities to create names. But the problem was they finally got a name for this project, and they're starting to develop this software. The problem was they didn't have the hardware for it. In the early 1990s, they didn't have the kind of these tablets and smartphones and smart TVs that a multi-usable software system could work on. But something else huge started happening in the early 1990s in the computer world. What can you think of that was a huge revolution in the early 1990s in the computer world? The internet, that's right. The internet is exactly right. That's what the internet's really, it's not when it was created, but that's when it really started to become available to everybody. And so although Project Java was in real trouble because the hardware wasn't there, they said, you know what? What if we took this Java stuff and tried to make it work with this internet thing? And it worked really well. Java was a way to connect web pages and the HTML world to more of a programming world and create dynamic web pages. It really, in the early 90s, became the thing to make really cool websites. Now, other things have developed since then, but Java is still used in that regard. So Java was formally introduced to the world in 1995 as the thing, and it is still a widely used programming environment. I know I've had kids every year come to me and say, Mr. Wilkes, I need to learn Java. And I'm like, why? Like, these are grade 9 kids. And I'm like, why are you so driven on that? Because you can do Minecraft mods with it. It's like the cool, okay, yeah, let's do that. So, hey, if they take computer science for that reason, that's great. But there are other things, right? Last year at the University of Manitoba, some students went out to look at, they have a thing where you can program weather satellites. Like they can control weather satellites. And when they sat down for the session, the code was in Java, right? When I was at the U of M in the fall of this year, I saw some graduate work being done there, and they have people programming Roombas. You know those little vacuums that move around the room? In Java, right? So Java is not a dead language at all. It's a very robust language for programming. It's not the language, depends what you're doing. But again, it is a very robust learning language. It's a great language to learn on. And it is the language that is being taught post-secondary. I showed that to you yesterday. So let's take a look at how it works. Okay, so with Java, you have the language itself, the code that you write, and an interface to write the code on, right? Or a development environment. Now you had that in C# as well. In C#, you had the Microsoft C# environment. and the C# programming language. The thing about Java is there are multiple ways you can run it. But when you write a code in Java, it goes through 5 phases. The 5 phases are edit, that's you writing the code, compile, load, verify, and execute. So I'll just briefly go through this. I'm going to try and speed up my presentation here a little bit. Okay, so the phase 1 editor phase, that's you writing the code. And you need to write it in a code editor. Now the code editor can be incredibly simple. It could be something as simple as Windows Notepad, because code is just text. But what's better than just like Windows Notepad is using something that's called an Integrated Development Environment, or an IDE, which allows you to color code your code and helps you track down errors and does things like auto-complete lines of code, or what we call IntelliSense, where you guys may recall that from C#, where you just have to start typing it, then you can hit enter and it finishes the whole line for you. That's way easier. So yes, we're going to do that. We're going to work in a development environment, okay? Once you've written your code, you save it, right? You save it on a hard drive or a disk somewhere. When code in Java is saved, it's saved with the extension .java. Like a Word file is saved with .doc, or a picture saved with .jpeg. Java code is written and saved with .java. And the integrated development environment will take care of that for you. You don't have to worry about that. Okay, now you come to phase 2. You've written your code. It will now compile your code. Now again, you don't need a fancy development to do that. All you need is what's called the Java API to compile your code. Luckily, when you used an integrated development environment, it takes care of all that for you. So it compiles your code for you. And what Java does is it turns your code into what's called bytecodes. Bytecodes is code that can run on any computer or any piece of hardware, okay? What it does is it turns your .java file into a .class file. There's that word again. Remember I said it's the most important word you're going to learn this year, okay? So compiling your code turns your code into a different file. And again, you're not going to have to worry about this because the compiler will take care of it for you. Then in phase 3, it loads your bytecode into memory. And when it loads it into memory, it possibly has to connect your code to any other code that you talked about when you wrote your code. Like let's say you made a reference to some graphics that you didn't write, but some class that somebody else wrote, you said, oh, I want to use their graphics code. It'll then load that graphics code into your code for you automatically. And that's that idea of classes. You're connecting your code to somebody else's code, okay? And that can be done through somebody else's code that's on your computer, or it can even be done across the internet. Like that's the idea of connecting that code together makes things a little more robust. That's phase 3. Then in phase 4, it runs a security check. And that's because in Java, you can make 2 types of programs. Apps, which are just running programs, and applets. What an applet is it's a piece of software that runs through a web page on the internet. And you've probably encountered these before when you're on the internet, like little programs that are running off of websites. The thing about applets are they have a higher security feature to them. Because think about it. You don't want to be able to go on a website and then all of a sudden that website can start rewriting your hard drive. Of course not. You don't want that to happen. It could be like some sort of virus then at that point. So applets have restrictions to them, things like you can't read and write you can't write files. But apps are full running programs. You know what you're doing there. It can do everything. If you wanted to rewrite files on your computer, it'll do that for you, okay? So app is a program. Applet is something that runs over the internet remotely, okay? So in phase 4, this is going to happen, okay? And it runs through something called the Java virtual machine. That's already on your computer. You don't got to worry about it. You've probably seen this before. Java update. Often on computers you have to do that, right? So in phase 4, it verifies that your code passes the security check. Okay, did it match the security restrictions? Because if it's an applet and you're telling it that it should be able to rewrite files, it'll go, no, 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 you can't do this. I'm sorry, you can't do this, right? So that's the security phase at phase 4. Okay? And then finally, phase 5 is where it actually runs. Okay? So as it goes through the phases, at phase 5, it finally executes your software. The good news, you don't have to worry about any of this. You really just work here at phase 1. You write the code, and then you click a button, and you should be at phase 5. But that's what's going on inside the computer, is it's running through all those phases. Okay? We're going to stop here today, because I wanted to get through that just history lesson with you guys. And we're going to pick up on it tomorrow, and we're going to write our very first piece of program. So exciting. And how do I stop this now?